today I'm going to be talking to you about Maslow's hierarchy of needs applied to software and also your software career as well. So if you don't know what Maslow's is, don't worry. I'm going to talk about what Maslow's hierarchy of needs is and like why it was created in the first place and why it matters. And then we'll talk about how we can apply this to software and create our own software hierarchy of needs, and then talk about how this applies to career paths as well. So for those of you who are new to Maslow's hierarchy of needs, basically it is this right here. Surprise, surprise, it was created by a guy named Maslow, I think back in the 40s. And basically the idea behind Maslow's is you need some of these lower building blocks before you can kind of graduate up to these higher building blocks. So for instance, like at the very basic level, at the bottom there, physiological needs, you need things like water, food, shelter, and those kinds of things before you kind of graduate up and start worrying about like your safety needs, like, you know, do you have your health, property, those kinds of things. And then you can keep moving up the chain to love and belonging, where you start worrying about relationships. And then once you have kind of those three things in place, you can start worrying about your esteem and, like, you know, your freedom, your self-esteem, those kinds of things, before you get all the way to the top and start trying to be the best person that you could be. So the reason behind Maslow's and why they created this in the first place is really Maslow's describes why people behave the way that they do and their motivations for doing so. So the idea again is like these lower needs must be fulfilled before you start moving up to some of these higher needs. So like if we look at Maslow's again, if you don't have any food or water or shelter, you're probably not going to care much about building relationships because, you know, food is more of a level 1 thing, and, you know, relationships is more of a level 3 thing. So this is kind of the idea behind Maslow's is you're going to prioritize these lower things before you start moving up the chain. And then, you know, you can kind of use Maslow's to decipher why people are doing the things that they're doing. So that's kind of Maslow's in a nutshell, but how do we apply this to software? Well, I don't know about you, but I've definitely come across code in my career where I'm like, why did they do it this way, right? Like, you know, did they not know any better, or, you know, was it done for a specific reason? Like, is there a reason why things are built this way? Like, is it even safe to change it to something else? You know, are there tests around this thing? I've just come across that situation tons of times in my career. I'm sure many of you have come across this as well, even probably today, where you just come across this code that you're not really sure why things were done the way it was done. So let's kind of build our own hierarchy of needs to try and decipher why things are done the way that they are, and kind of also apply this to where people are at in their careers as well. So I'm going to propose a hierarchy of needs. These are just my opinions, but the bottom level I'm going to put on here is something I'm going to call make it sustainable to work. So these are things like, you know, I feel psychologically safe to work. Like I feel comfortable, you know, asking questions, you know, having hard conversations with the team, and know that I'm not going to have some blowback from some of those things. And also like understanding why you're working on what you're working on, because if you don't really understand the why, you're not going to have that big picture of knowing why you're working on something that then can kind of inform like, should you even be building this thing in the first place? Or like, is there a better way to do these things? So I think that's also a fundamental part of it too. And then also knowing the timelines and expectations upon you and feeling that those are reasonable. And the reason why I put this is some of you may have seen this, I think it's like a YouTube, or it might have been turned into a GIF as well, where basically the same artist drew these 3 pictures, but under three different constraints. So you can kind of see the far left one, they had 10 minutes to draw that picture of Spider-Man, and it looks really good. But then, you know, notice like, you know, the middle one, they only had a minute to draw that picture of Spider-Man. So exact same artist and everything, but the only difference was the time constraint that was put upon him. So you can see definitely that's more scribbled and less clear, probably because they're rushing. And then the far right one, they gave themselves 10 seconds, but actually took 12, and they created something that looks something more like what I would draw, because I can't draw whatsoever. And you can see like the lines aren't even refined. So like even though on the far left things look really clear and everything's really well defined, you can tell that they're rushing too. So like even some of the basic things like the lines weren't crystal clear and weren't crisp and stuff like that. So exact same artist, but you put 3 different constraints on them and you can see you get 3 different outputs. And this is also kind of where like the sustainability piece comes in, because if somebody has a very short time frame to do something, they're probably not going to be creating a quality solution and kind of moving up this chain that we'll see here in a second. So that's kind of why I see that this is kind of a fundamental building block, because if you don't have some of these things in place, it's going to affect everything else upstream. All right, so once you have a sustainable place to work, then you can worry about what I'm calling make it work. So this is just very simple of, can I get the code to work at all, and does it do what I want it to do? So we'll talk a little bit later about like where people earlier in their career land, but a lot of time they spend right here in just trying to make the code work. But once you make it work, then you can worry about making it maintainable. So this is where, the code is clean and, the code is easy to read. You can build and deploy it in a repeatable, hopefully an automated fashion. You can also change the code confidently. So you have things like automated tests in place. You have, a CI pipeline to catch any issues, like if a test breaks. Also, you have good tests that, when the tests break, there's actually a problem. But you can move through the code and change code confidently. And then also, this kind of goes back to the clean part, but logic for a particular behavior is centralized. So if you need to change like a certain business rule, let's say like how you price something, you don't have to go change it in 20 different spots. You just change it in one spot. So once you can kind of make things work, then you can start worrying about making the code maintainable. And you may have heard this phrase like, make it work, make it right, make it fast, and the make it fast is optional. It's kind of the same principle of like, first you got to make it work before you can even worry about making it maintainable. And then next, after making it maintainable, we make it fit. So what I mean by that is, let's say you're slinging some JavaScript code. Your JavaScript code should look like other JavaScript code in the ecosystem, and not like C# or Java or some of these other languages, right? So if you drop like an experienced JavaScript person into that project, they shouldn't have a lot of like surprises. They should kind of know what to expect and expect some of those idioms of the language to be followed. So that's part of make it fit, but then also the code looks like other code in that application that you're working in, the team that you're working in, and the organization that you're working in. So what I mean by that is, let's say you're introducing a new like pattern or something like that in the application. I think at first that should be a conversation before that just kind of gets introduced, if it's like a broad sweeping change, right? Or let's say the place you're at is an Azure shop, and then you want to start using AWS. Like, to me, that's not something that should be done right then. That should be like, okay, let's have a conversation first of like, okay, why do you want to do this big change from Azure to AWS, and like, does it make sense or not? So this is not saying like, hey, you always have to follow the patterns of the existing code base, but it's more like, hey, if there's a big change you want to make, like, we should probably have a conversation first. Otherwise, we can just make things fit within the actual application, just to make sure that everybody's on the same page. And then we're not like, oh, I can see, Bob always uses like this pattern, but then Susie always uses this pattern. You can, as you're going through, you can kind of tell like who was the person that created that piece of code. So ideally, you want all of the code to look like anybody on the team created it, or any pair on the team created it. All right, so then the last thing, so let's say we make the code work, we make it maintainable, we make it fit within our application or team or organization. The last piece is make it only if it makes sense. And so what I mean by that is, should we have even built this code in the first place, right? Or like, did we solve the real problem that we're going after? Like, for instance, let's say you're making an export to Excel feature, asking the question of like, okay, why do you want the export to Excel feature? And then finding out like, oh, well, I exported to Excel because, I want to like reformat things and like change column names and change the formatting. So then I can upload it to this other system. It's like, okay, well, does that system have an integration point that we can just bypass this middleman step, or at the very least get it in the format that you're looking for, right? So kind of asking those deeper questions of like, hey, let's make this feature only if it makes sense. Or if something doesn't pass the sniff test, maybe asking more questions to get to the why behind why a feature is desired. So then how does this relate to careers? Well, think about yourself. So like, where do you find yourself spending a lot of your time on this pyramid? And I found both like in my own experience when I was early in my career, and then also working with people earlier in their career, a lot of that time is spent in make it work, right? Like they're not really worried about making things maintainable to start with, or making it fit, or only making it if it makes sense. A lot of times they're just focused on like, okay, I'm trying to get this problem solved, and I need to get this code out the door. And they get like maybe 80-90% of the way there. They just need some help and guidance along that last 10 to 20%. So if you're early in the career, I found a lot of time gets spent in that make it work section. And then later in your career, it kind of gets all over the board. Some people end up spending a lot of time in like making it maintainable or make it fit, or a lot of times also making it only if it makes sense. But then sometimes they go back down to the bottom of like, if you get dropped into a new organization, a new team, something like that, there may be some things that, aren't quite, in a good spot. So like it kind of, again, shakes the foundation of all of these other things, right? So like if you don't have trust on your team, that's going to shake the foundation of pretty much everything that you're doing. So focusing on some of those pieces and getting those in place, so then you can focus your time higher up this pyramid after you get some of those things in place. And I always like to say, like, software engineers are the last line of defense for a bad idea. So sometimes there's things that people think are really good ideas, but then it comes down to like going to implement it. And then it's like, okay, what are you actually trying to do here? Like, there's actually a better way of doing this that solves your problem, and an easier way to maintain for the engineer side of things. And it might even be better for the end user at the end of the day too. So if we kind of go back to that question of why did they build it that way, like where you get dropped into this code where you just don't understand why things were done the way that they were, you might ask yourself, like, where were they at on this pyramid? Like, were they just in the make it work phase, or were they somewhere higher up? And then also just, where are you spending your time? Like, are you spending 80% of your time in make it maintainable or make it work? Or just kind of think about like where you're at and where you're spending your time. Like, are there things that you're doing 0% of the time that maybe you should be adding to your workflow as well, and start integrating some of these questions and concepts into your everyday work. So some takeaways from this, hopefully you got an understanding of Maslow's hierarchy of needs, and also just how we can apply it to software and careers as well. And then also just kind of like in the back of your mind, think about like, are there other applications for Maslow's hierarchy of needs? Because this mental model of like, you need this before you need that, before you need that, is kind of a powerful mental model to think about and reason about certain situations that you get into.